Okay, good day. I am Mr. McCully. This is Honors Algebra 2, and this is the video presentation for section 4.6, the quadratic formula. Let's get right to it. Today we have a couple learning goals. We're going to solve quadratic equations by using the quadratic formula, and then we're going to use the determinant to determine the number and types of solutions of a quadratic equation. All right, so what is the quadratic formula? In the last lesson, we learned about completing the square. And so completing the square is a fairly arduous process, and we want to simplify that. So what we're going to do today is we are going to develop a formula that takes the values for a, b, and c and plugs them into the formula and solves the quadratic equation for us. Now, how are we going to do that? Well, if you recall from the last lesson, if you are given an equation in ax squared plus bx plus c equals 0 form, and you want to solve for x, we're just going to quickly go over these steps. You're going to move the constant to the right side, and then you're going to divide both sides by a. If a is equal to 1, you're going to skip that step. We can't skip that step in this particular instance because a is going to just be a variable, and we don't know what it is. Then we're going to add b over 2 squared to both sides of the equation, and then we're going to complete the square. And then we're going to solve for x by using the principle of square roots. So we're going to complete this with a general. And so just quickly going over those steps, the first thing that we want to do is we're going to move the constant right. All right, so we'll be subtracting c from both sides. Then we'll have ax squared plus bx equal to negative c. And then we want to divide by a. And we have to divide each term by a. So when I divide ax squared by a, I'm going to get x squared. When I divide bx by a, I'm going to get b over ax. And then when I divide c by a, I'm going to get c over a. Now we're going to add, it's going to be b over 2, but if I divide b over a divided by 2, it'll be b over 2a squared. That's me dividing b over a by 2 to both sides. All right, so I have x squared plus b over ax plus b over 2a quantity squared, and I have to do that to both sides. All right, now we want to complete the square. And then we're going to start simplifying. When we added b over 2a squared to both sides, we made this into a perfect square. And just like in the last lesson, that becomes this x and this expression inside the parentheses plus b over 2a. And then on the left-hand side, we're going to start simplifying. So I want to square this expression, and I'm going to square the top and the bottom. So I have negative c over a plus b times b is b squared. 2a times 2a is 4a squared. All right, so I need to find a common denominator. All right, and so I already have an a over there, but I need it to be 4a squared. So we will leave this expression alone. It'll be x plus b over 2a quantity squared. But on this side, I want to add these two fractions. So to do that, I have to find this common denominator. And so I have an a, but I need it to be 4a squared. I'm going to multiply this c over a by 4a over 4a. Now that's just 1, and I'm multiplying that times negative c over a plus b squared over 4a squared. And so again, we're still simplifying here. And so now I have negative 4ac plus b squared all over 4a, because when I go 4a times a, I'll have 4a squared, and then I can add the numerators and the denominators are the same. All right, so now I still have this x plus b over 2a squared on this side, and I want to get x by itself. So the next thing I have to do is take the square root, and we have to remember M-E-M-B-E-R. Remember to add plus or minus. So I'll have x plus b over 2a equals plus or minus the square root of negative 4ac plus b squared all over 4a squared. Let's move this back. Now, negative 4ac plus b squared is not a perfect square, but 4 is a perfect square, and a squared is a perfect square. The square root of 4a squared is just 2a. And then I'm going to reorder the numerator. And so I'll have x plus b over 2a equals plus or minus the square root. I can't take it, so I'm just going to go b squared minus 4ac all over. Remember, the square root of 4a squared is just 2a, so I get 2a. And then I'm going to subtract b over 2a from both sides. Now the good news is, when I look at the denominators of these two fractions, they're the same. So I don't have to find a common denominator. I'm just going to subtract, so I'll have negative b, and then it'll be plus or minus the square root of b squared minus 4ac all over 2a. And lo and behold, we have solved for x. And so this is our quadratic formula. The quadratic formula, if ax squared plus bx plus c is equal to 0, then x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. This is something that we definitely want to commit to long-term memory because you will see it over and over again. A couple of quick notes. From this point on, when solving a quadratic equation, if a is equal to 1, try and factor. If that fails, use the quadratic formula. If a is not equal to 1, we'll just use the quadratic formula, and then it'll just be quicker. The quadratic formula will find all of the zeros of a quadratic, including the imaginary zeros. Those imaginary zeros will be complex conjugates of each other. So, just a quick example here. Solve the following quadratic equation using the quadratic formula. I'm going to label this value to be a. I'm going to label this value to be b, and this value here to be c. And the quadratic equation is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And I'm just going to plug in. So, b in this case is negative 5. So, negative 5 is going to be positive 5. Plus or minus the square root of negative 5 quantity squared minus 4 times 2 times negative 3 all over 2 times 2. That is the a. So we'll go up here and we'll simplify. So I've got my plus or minus the square root. All right, let's see here. So I'll have negative 5 times negative 5 is 25. 4 times 2 is 8. 8 times 3 is 24. 24 and 25 is 49 all over 4. And the square root of 49 is 7, so I have 5 plus or minus 7 all over 4. Now these are all like terms, so I can figure those out. 5 plus 7 is 12, divided by 4 is 3. 5 minus 7 is negative 2, divided by 4 is negative 1/2. And those are my two solutions. Now let's look at one that's a little bit uglier. This one says solve the following quadratic equation using the quadratic formula, and it looks right off the bat that it might be easier, and because I've got a leading coefficient of 1. Now I asked myself, are there two factors of 7 that add up to -4? And the problem with that is that these two would have to be negative, and the only two factors of 7 that are negative would be -1 and -7, which add up to -8. So I'm not going to be able to factor this. So again, my A is 1, B is -4, C is 7. And so I start with my quadratic formula, x equals -b plus or minus the square root of b squared minus 4ac all over 2a. So again, I have a negative, so negative becomes +4 plus or minus the square root of -4 squared minus 4. A is 1, C is 7, all over 2 times 1. And so we're going to simplify. So I've got 4 plus or minus the square root. -4 times -4 is 16. 16 minus 28 will be -12 all over 2. All right, we need to simplify this. So I have 4 plus or minus. Well, I've got the negative under the radical, so I'm going to put an I out front to begin with. And now I'm looking for factors of 12 that are perfect squares. 4 is a factor of 12, and when I divide 12 by 4, I'm left with 3. I know I'm done because 3 is a prime number, and that will be all over 2. And then I can take the square root of 4, so I'll have 4 plus or minus 2i square root of 3 all over 2. I have 3 terms, 1, 2, 3. Each of those 3 terms has a factor of 2. So 4 divided by 2 is 2. 2 divided by 2 is 1, but we wouldn't write that, so square root of 3. And then 2 divided by 2 is also 1, and so we wouldn't put anything over 1, and that is going to be our final answer. The discriminant is the part of the radical under the quadratic formula. It's the b squared minus 4ac. So if we look back here, the discriminant is this part of the equation. And what it does is it tells us the number and types of zeros that a quadratic will have. Now there's only three different possibilities. If b squared minus 4ac equals 0, then the quadratic equation will have one real solution. If b squared minus 4ac is greater than 0, then the quadratic equation will have 2 real solutions. If b squared minus 4ac is less than 0, then the quadratic equation will have 2 imaginary zeros. And so let's take a look at what that would look like graphically. So let's pull up our Desmos. And let's put in this quadratic equation. Let's put in y equals x squared minus, actually let's make it plus 4x plus 4. All right, now what would the discriminant of this thing be? Well, the discriminant of that thing, y equals x squared plus 4x plus 4, the discriminant of this thing would be 4 squared minus 4 times 1 times 4. That equals to 16 minus 16 equal to 0. Since this is equal to 0, this quadratic has one real solution. And when I look at it in Desmos, it crosses the x-axis at one place at -2, 0. Now, if I make a simple change, if I go y equals x squared plus 4x plus 6, well, if I plug it into this b squared minus 4ac, I'll get 4 squared minus 4 times 1 times 6. That'll be 16 minus 24, which will give me -8. And so if I go back to Desmos, and I plug in that 6 there, you'll notice that this graph no longer crosses the x-axis. So if b squared minus 4ac is less than 0, -8, then the quadratic equation will have 2 imaginary zeros. Since this quadratic has no real zeros, it must have 2 imaginary zeros. Now if we change it to just y equals x squared plus 4x plus 2. Then I'll have 4 squared minus 4 times 1 times 2, which will be 16 minus 8, which will be positive 8. And if we go back to this and we change that to a 2, you'll notice that this thing crosses the x-axis in 2 places, and I'm going to have 2 real zeros. Find the value of the discriminant and determine the number and types of roots. So again, I'm just going to use that b squared minus 4ac. In this case, that'll be negative 1 squared minus 4 times 6 times 5, which will give me 1 minus, let's do it easy, 6 times 5 is 30, and then 30 times 4 is 120. This will be negative 119. And since it's a negative, so the value of the discriminant is negative 119, and that means that there are 2 imaginary zeros. And again, there are only 2 other options. If this number came out to be 0, there would be 1 real. If this number came out to be positive, there would be 2 real zeros. Finally, let's talk about this. The evil Professor McCulley is shooting sharks with lasers on their heads out of a shark cannon at fleeing students from atop his tower that is 200 feet in the air. If the shark leaves the cannon with an upward velocity of 100 feet per second, how long will the shark be in the air if the function that models the situation is h of t equals negative 16t squared plus 100t plus 200, where h is the height in feet and t is the time in seconds? So if I think about this quadratic equation, I know that because it is t squared, it's a parabola. Because the leading coefficient is negative, it's going to open down. And because the constant is 200, it has a y-intercept of 200. So this isn't a good enough graph for an answer on a quiz, but it gives us a good idea of what we're looking for. I know that this thing has to be 200. I know that it opens down. I know that this is time, and I know that this is height. So I'm looking for this value here. There will be a positive one. There will also be a negative one, but we're not going to look for that one. So I'm just going to use the quadratic formula to find where it intersects. So I'm just going to plug this into the quadratic formula, and I'm going to say that x is equal to negative b, which is 100, plus or minus the square root of b squared, which is 100 squared, minus 4 times a, which is negative 16, times c, which is 200, all over 2a, which would be 2 times negative 16. And I'm not even going to mess with that. I'm going to go back to my Desmos. I'm going to pull up the scientific calculator, and I'm going to start with a parentheses. And so it was negative 100, and we'll start with the plus, we'll hit the square root button. Now, negative 100 squared is going to be negative times a negative, so it'll be the same as saying 100 squared minus 4, and then we'll go times, and then it'll be negative 16, and then another multiplication, 200. We'll go out of the square root, and then we'll close the parentheses. We'll hit the divide key, and then we'll go, we know that 2 times negative 16 is negative 32. All right, so when I enter that in, I see that I have a negative here. Now remember, we said that there was going to be a negative value, and we're just going to ignore that. So when we do the plus part, that one doesn't seem to work. So here's what I'm going to do. I'm just going to come back over here. I'm going to change this to a minus. It says 7.843, and that is what we're going to write in seconds. 7.843 seconds. So you have 7.8 seconds to get away from the flying sharks. That's all I got for today, folks. So The Mandalorian fun fact of the day. For most of Season 1 of The Mandalorian, the title character, voiced by Pedro Pascal, isn't even in the armor. 2 body doubles fill the armor for all but one moment in Episode 10, where a droid and the audience sees the face of the Mandalorian. The rest of the time, he has his helmet on. Well, that's all I got for today, folks. You have a good day. Bye.